And you will introduce me?
Yes, if you wish.
Okay. Just so that I know if I should start talking immediately.
Oh, you can, no problem. Go for it.
Yeah, oh, here we are. Hello, everyone. Thank you so much for joining me in this session here. We will be diving a little deeper into algorithmic bias. Obviously, we talked about this afternoon in our session on sort of generally what we do at SU. I'll start sharing my screen, and on it you should see, and just double check that I can see the right screen.
I can see you very well. Absolutely.
You see the QR code as well?
Very good, yes.
Wonderful, because what we talked about this afternoon, of course, was that we have this research publication which we've released to our members, and with this QR code you can actually get a preview of that. You can get the first part of it if you were interested, and if you want to hear more about what we wrote there. So as I mentioned this afternoon, you know, we talk a lot at SU about what the implications are of our technologies, right? We really aren't the place where you would go to learn how to program an AI, but we can talk to you about what the impact of that AI is and what it can be used for, what we can leverage our algorithmic technologies for to achieve in the world. And as we mentioned this afternoon, well, this afternoon for me, very early for some of you, we wrote this research paper really about the effect that we foresee that algorithmic regulation will have on businesses, right? Just like we saw with GDPR, businesses will have to scramble to understand how to sort of like retrofit their technologies with these regulations. And that's one part of what we do, and it's a very important part. But the second part is also we educate people about actually understanding how things within the technology go. We see this specifically, well, I see this because my work is in this space, specifically in AI and algorithmic technologies that are used to automate decision-making, where because of the democratizing forces of our exponential technologies, it's now very easy to train or to design an algorithm, even if it's just for fun, but you know, we don't always understand what the results of that can be and how they can sometimes lead to nefarious outcomes, such as biased algorithms or problematically biased algorithms. And really, that's what I want to talk about today. And as I mentioned this afternoon as well, we usually have a 4-hour workshop where we really get people sort of to sit down, design their own algorithm, and figure out how they want it to function. And we unpack the algorithm and we show where and how it may have become biased along the way. I don't want to take 4 hours of your time today, but I wanted to sort of give you a bit of insight as to how we do that. And so we'll be using the polling function. I'll send out a poll in a moment to sort of get you in the right mindset to make those kinds of decisions. So really what we're talking about is if I were to say design an algorithm, right? And in this story, I'm designing an algorithm for in order to hire someone. I'm designing a hiring algorithm, which is actually where we see a lot of automated decision making happening when people sort of get a lot of resumes and they have to make a decision who to hire. If you were to hand design an algorithm, you might say, well, these are the characteristics that I want the people that I'm going to hire to have. Let's say it's these 5. What you then do is you put that in an algorithm, right? You automate that. And then what the algorithm does is once you get a number of applicants for your job, it will tell you this is the person you really want to hire. Now, you may have different ideas about what would be important characteristics for you to pursue in your hiring. But let's say we're working on a hiring algorithm, and one of the things we're looking for is people that have a lot of integrity. Now, I'm going to launch a poll. Which I can do here. And the question is, if you're using an algorithm to help you find people with integrity, what is the most important quality that you're looking for? Is it that people are between the ages of 36 and 50, that their acute stress response is fight, so you know the ones are like fight, flight, freeze, and fawn, I think, is it fight? Or that they wake up between the hours of 4 and 7 in the morning? Those may seem like silly silly characteristics to you, but I invite you to have a vote on which you think, to find integrity in people, is the most important characteristic. And I'll explain more as to why we make this sort of like weird, mysterious vote soon. I'd also like to invite someone who's voted to come on stage here with me and tell me why it was that you chose this answer. So let me know if I can see the polls. We have one vote, so it looks like it's working. So let me know. And then if someone is willing to raise their hand, I would like to ask you to come on stage and share with me why you voted the way you did for currently that one person that's voted, but please, more people join us. We are seeing, what is this vote? The letters are very small. They wake up between 4 and 7 in the morning. So I would like to, now we have a split vote, for one of you to raise your hand and come tell me what your reasoning is for those two. Or if you don't feel like that's not actually that reason, because I hear this a lot, actually the other two are just bad reasons, then you can come tell me that as well. If not, I'll give you another couple of seconds. And otherwise, I see that Tisha's in the session. I will call on you to tell me why you voted the way you did, because I know you voted. So if anyone wants to share, raise your hand, please do. I'm seeing no votes for the age question. So maybe some people are very, aware of trying to not be ageist or something, or maybe you actually think a fight response is good. There we go. It's a split vote. Well, I'll close it for now, but I'll have a second poll later, and I'll ask you again to raise your hand if you want. The reason why I ask this is because in the workshop that we do, we actually ask people this question. We ask them, think of all the data points we could collect about you, and what would be important characteristics that we could filter out and use to build a decision-making algorithm. The way we do this is actually, we send them one of those like personality quizzes, right? Do you know the ones on like BuzzFeed that tell you what kind of bread you are? And it's always like weird questions. It's one of those. So we already have that data about them. And then we tell them, okay, now with these questions, tell us how you would design your algorithm if you were to find people with integrity. And this is what they do. So I'll share some results from our actual workshop. This is one group that we worked with. They designed their algorithm, and you can see it here on the side, to divide the weight of the algorithm. I'll go into more details in a bit. Divide the weight of the algorithm so that it accounts for age for 20%, the stress response for 20%, and the waking time for 15%, having the most important characteristics to find integrity being that they're between the age of 36 and 50, that they have a fight response, and that they wake up between 4 and 7. These two are tied at the top, right? Stress and age are tied. But this was actual people trying to build an algorithm finding integrity, right? And obviously they had more data than you do, but they did. This is the decisions they made. And just to show you another one which has different results, I'll pull you again. So what if instead, now we're hiring again, but now we want to find people who have financial responsibility. Here's what we're going to look for. We're either going to look for people who drink 4 caffeinated drinks a day, people who have a flexitarian diet, so that means that you do eat meat, but not very often, and you often eat vegetarian meals, or that they have 3 children. Those are the 3 you can pick from. Remember, you're looking for someone, you're hiring someone new, and you want someone who has financial responsibility. I have one response so far. This is actually my favorite of the 3. They have 3 children. It's so specific, right? It's so specific. Why would you want someone to have 3 children? I know I only gave you like 3 weird options, but these are, again, their actual results. So if someone wants to share their reasoning, please do raise your hand, because I would love to hear who thinks that having 3 children is the best indicator of having integrity. I'll give you a couple more moments to answer the poll here. And again, you may think that these are, silly categories to make this decision on, but I can tell you these are actually quite indicative of some of the data points that are actually being used in actual decision-making algorithms. So we have a couple more votes. Anyone want to share? I would love to see if, oh God, I made it all go away. Where is it? The poll. Here we go. 6 people have voted. Let's give it another second. See if you want to have another vote. No one willing to share? I'm going to call on Tisha then, because I know she has opinions in this place. So Tisha, if I could ask you to join me up here on the stage, please. There she is. Now, Tisha, I know we have talked about this a lot. There you are. Can you share with us what you voted?
In the I didn't vote in the second poll.
Oh, okay. Well, then we'll have you vote right here, right now. Okay. Which of the 3 would you pick?
I would.
Remember, you're looking for financial responsibility.
So for financial responsibility, they have a flexitarian diet.
Okay. And why would you pick that one?
Because they've got to have some discipline.
I see. Oh, okay. I like that reasoning. Yeah, I like that reasoning a lot. You also just influenced 2 people to vote that way. We just got 2 more votes for the flexitarian diet. So it looks like you've actually convinced some people. Yeah. Thank you so much for sharing.
No problem. Thank you.
All right. So as I mentioned, this again were results that we saw in our actual workshop. So we had people design an algorithm to automate decision-making around financial responsibility. So identifying financial responsibility in people. What this group chose is that someone should drink 4 caffeinated drinks. They were very creative with their percentages, as you can see. And second on that was they agreed with Tisha, a flexitarian diet is a great indicator of actually having financial responsibility. Here we have some disagreement in the chat, but children are more responsibility, Sarah. I mean, that can be that can be exact the kind of reasoning, right? These are the kinds of decisions we make. And so again, I'll just get you sort of the insight of how we actually do this, because what we do in the workshop is an actual we have them build an actual algorithm, right? So what happens is we have them take that personality quiz, that BuzzFeed quiz, defining what kind of breed they are. It actually is the way in which we scrape data about our participants. So each person is represented by a set of demographic data. We ask them, how much coffee do you drink a day? How many children do you have? What's your fight or flight response? Then we design the algorithm, the participants design the algorithm, and use your design decisions to distribute those weights and rank the responses, right? It then creates a ranking of all of the applicants, of all of the participants in the room, to sort of understand who would be the best fit for this particular algorithm. Technically, the way that works is, just in case you're interested, what they do is they give survey questions a weight out of 100 and rank the answers, and then to get the value of each characteristic of each survey question, the response, so the sub-characteristic, is multiplied by the weight of its characteristic. So if someone's a good hire, is tracked as a score, right? So that's the sum of their characteristic values. If, for example, we have a question about what's your favorite mode of transportation, if that's given a 5% weight and bike is ranked second, there's 6 answers there, then the value of riding a bike is 5 times 0.5, 0.5 is 0.25. 5 being because there's 6 answers and bike is ranked second, right? So it's closest to 6. Minus, well, the actual 6. So that way the algorithm is built to select individuals whose characteristics correspond to the preferred ones. This is basic algorithms, right? That's a basic algorithm. Of course, what we hear a lot about today is more machine learning, deep learning, self-learning algorithms. So the ones that you don't have to hand design, the ones that you don't have to say, okay, I want you to do this exactly, and then it automatically does that. So let's say you're, okay, I want my hiring algorithm, but I want to do machine learning next time. I don't want to tell the algorithm what the characteristics are that I'm looking for. I want it to infer from what I think is a good hire, just sort of like understand that from me, and then I want it to tell me who next good hires are. One way to do that is to look at who your current employees are and which one of them you think are good, have turned out to be good hires. Now, here's where things get awkward. So I want you to vote. These are your employees. In the chat, please tell me which of the 2 do you think are your best employees? I'll wait. You can say 2 letters. So AB, BC, CD, CA, BD, whichever ones you want. Let me know. Because what we're doing, for what type of job? That's a great question. We're just talking good employees. That's a good question. I'll tell you more about the job later. Just good employees. But I will say I commend you on asking that question, because it is exactly those kinds of questions that we should be asking before we start. You know, often we like to jump immediately to sort of the kinds of technologies that we want to deploy. And sometimes we don't actually think about what the implications of that are. So we have some votes. Now, I'm seeing a lot of C and I'm seeing a lot of A. It wasn't on accident that I asked Tisha to join me later today, because earlier just now, because I was kind of expecting you to then maybe be a little bit primed to vote in a certain direction. Now you have your employees, of course, they're all represented by certain characteristics, right? Let's say these are the ones that you said were good, and it is kind of the way you've voted, because I've kind of primed you a little bit by putting myself and Tisha in front of you. Of course, it's very awkward sitting here, right? I'm sitting here right in front of you. You should be voting for me, obviously. And so this is the way that you might train an algorithm, by saying, okay, so I want these 2 employees. I'm already telling you, like, that hasn't been a very neutral process, hasn't it? It hasn't been very, like, have we looked at their performance scores or whatever? I haven't actually given you information about the job. But what now happens is this AI then goes in and it says, okay, so it's deduced from these characteristics, looks at those 2, right? It's looked at those 2 employees, and it has said, okay, so I've seen the kind of characteristics these 2 have. I've now deduced what the best characteristics are for us to start hiring from. In a new pool of applicants, it will then select those people that most closely adhere to those characteristics. So similarly, what happens here is we collect the votes, right? And we match those with the demographics of the corresponding person. Again, we have this data about the people because we've either had them taken a quiz or whatever. The algorithm then creates a model to predict how good of a hire a person is based on their characteristic, and the output is sort of like the impact or the importance of each characteristic to the model, which we then extract for presentation purpose, which was the graphs you saw earlier. Again, technically speaking, that means each person that has been voted for has a score, right? Each survey question or each characteristic is a variable for the algorithm, and the target in this case is how good of a hire is. The algorithm learns which survey responses are best indicating at a good hire. So if we ask people, which we do, what their Hogwarts house is, we tell them, okay, so the algorithm looks at the responses for Hogwarts house and it assigns a value to different responses, and that's where it derives feature importance. And then when it gets deployed on a new set of people, the algorithm gives them a score for how good of a hire based on the cumulative values they have, right? So what did I just show you? In the poll, I asked you to show your preference for specific characteristics. So that in that sense, we're directly coding an algorithm, right? When I asked you to vote in the chat, I used your input. I mean, I predicted your input, but to train a supervised machine learning algorithm to find what I believe is a good hire. When we ask people why they choose the way that they choose, they have opinions that are sort of very obvious to them. Well, obviously, as Sarah said in the chat, like, having children is more of a responsibility than drinking 4 cups of coffee in the day. Or as Tisha said, like, well, actually, maybe it's more to do, oh goodness, I just made you all disappear again. Sorry. It's actually to do with having some discipline, which we can search for by having people have a flexitarian diet. So that's the way we indicate that. And when it comes to how we code these things, when it comes to, how we think about what are the important characteristics, or who of these people do I think is actually a good hire, we have very human responses to that aren't necessarily backed up by data and we can have it backed up by data, but it takes more time. And in the time that takes, we've already made our human assumptions. And this is something that's really important for all of us to remember, is that any algorithm that we encounter, any automation of any decision is automated by humans with those kinds of human responses. And as I mentioned before, there are a ton of data sets out there about you and me and all of us. All the stuff on the left here, this was from a source in 2017. This is already known about you, about any of us, about all of us. All the data you see there on the left. And it feeds decision-making algorithms like the one you see on the right that make very real decisions about you. And if you think, this data on the left, it's like, okay, that's kind of intrusive, but there's a ton of other data that emerges when we're throwing machine learning in the mix. So there's an example from a hiring algorithm, which is, again, a common used example. This was a company that had made their own hiring algorithm, just like we did just now. So they had machine learning look at what they thought were good hires. There's not the Amazon example. I'll talk about the Amazon example in a moment. They had a pool of people that applied, and so they trained an algorithm to find the good hires. What they then did is they audited their algorithm. So they looked at exactly what the values were that the algorithm was finding important, what characteristics it had learned to think of as important, just like we did earlier when you saw that you completely like laid out with all the percentages and the rankings. What did they find? That this hiring algorithm that they had made, the most important characteristics that it was looking for, it was that people were called Jared and that they played lacrosse. That's how silly these kinds of characteristics can be. And we can laugh about this because it's weird, right? Like, okay, Jared and lacrosse, that's interesting. Why would it care about Jared and lacrosse as much as it does here? Well, if you think about it, being called Jared and playing lacrosse is essentially coded proxies for being a white male, right? So this is a rather problematic hiring algorithm. They didn't use it. But this is what's interesting, right? Is when we start looking under the hood of our algorithms, it is because of the nature of machine learning and other algorithmic-based technologies that the divisions that are made on the basis of them will actually be explicitly visible rather than implicitly present, as is the case in humans hiring humans or other non-algorithmic-based processes. There are no such things as implicit biases in code. There are only explicit ones. And although the biases introduced into our automated decision-making systems will mainly have been introduced because of the implicit biases of its creators, the process of creating and training an algorithm on those implicit biases can actually help in making those biases explicit, right? With an explicit view on the biases of an algorithm, the discussion of what's fair and what's just will stand the test of time, and regulation can become concrete and actionable. That's what happens when you audit an algorithm like they did. So suddenly they're seeing, okay, if we're looking under the hood of this algorithm, what is it actually looking for? It's looking for people called Jared who play lacrosse. And if you think about that, you can also understand why it might be looking at that. Now, when I talk about this subject, I usually say, well, there's two big dangers, right, with this. Is one, you might be excluded. If you're not called Jared, you don't play lacrosse, you may actually fall victim to the exclusion by an algorithm. Second is if you're a business owner or any kind of person who seeks to leverage algorithms because of their explicit nature, what you're doing, any blind spot that you're coding into your algorithm, you're actually hard coding into your models, right? So those are two dangers. Turns out that's not enough for everyone. Some people need more. So this is from, I'll have you guess in the chat, this is from the year report to stakeholders from a big company saying another danger of algorithmic bias. They say some AI scenarios present ethical issues. If we enable or offer AI solutions that are controversial because of their impact on human rights, privacy, employment, or other social issues, we may experience ... So they're aware of some harm that they might incur if they don't deal with the ethical issues right. What do you think that harm is, and who do you think it is? Let me know if anyone wants to guess. And yes, Fabrizio, that is why Amazon didn't hire you, because you're not Jared. You don't play lacrosse. Anyone want to take a stab at why they think AI ethical issues might be dangerous? brand or reputational harm. This is from Microsoft's annual report for their fiscal year end to their stakeholders. So the reason why they started caring about algorithmic bias is because the world has started caring about algorithmic bias, and because the public is holding big companies accountable for whether they're using just, fair, and equitable algorithms. So the big companies, I mean, this is what gets me like super jaded, right? It's like, oh, they don't care because, you know, they think it's the right thing to do. They care because they think they might incur brand or reputational harm. Ultimately, I don't care. We have to talk about this, so this is the way it is. Fine. But just so we all understand, this is becoming, the education about this is catching up. Now, when we talk about bias, what we talk about, and for those of you who are at our session today, I promised we would talk about whether it's possible to design an algorithm without bias. This is from a source from 1996. So these are two old like computer scientists from back in the 20th century who wrote, "We use the term bias to refer to computer systems that systematically and unfairly discriminate against certain individuals or groups of individuals in favor of others." Mind you, the foresight, right? Understanding in 1996 this was about to be a problem. Now, there's one thing we need. So there's really nothing new, right? We've known this for ages. But one thing I want us to be mindful of is that when it comes to bias, a thing to be aware of is that every single algorithm has a bias. They have to. Because if you are designing an algorithm to, say, find the difference between squares and circles, then you will train an algorithm that has a bias for round shapes versus angular shapes. That will be its bias. That is the intended bias. That is the design. Without a bias, an algorithm can't do anything, right? On top of that, you can have an unintended bias, an unintended discrimination of factors, people, or variables that you did not intend. And that is the kind of bias that we talk about when we're talking about algorithmic bias. But important to remember is that there is no such thing as a bias-free algorithm. We need a bias, otherwise it's not actually doing something. Now, there are many types of biases in the world. I will highlight a few of them here just to give you a bit of an overview, and then there's much more. These I will leave here, and I really see those as living on a spectrum on three sort of different corners of that spectrum. The first is our personal background showing up when we train the data. This is exactly, and most of you will be familiar with this example, what happened in the Amazon hiring example, right? So they did the same thing, that a machine learning algorithm look at what were successful hires in the past and use that to select people for new hiring. Now, who were successful people that they hired in the past? They were predominantly white heterosexual males, because what the algorithm looked at was who was promoted often, who was hired more over other people, and who was considered most successful in their job. Now, so it was just replicating the existing biases in the workplace. Another thing, that's the bias data. So the training data is really already sort of tainted, and it is already biased in and of itself. If I say, okay, I'm using a hiring algorithm and I'm training a machine, then I may train it on people that look like me or people that I know, people that think like me, etc. So I'm actually not creating a sort of like diverse hiring force. The other thing that can happen is if you have a statistical distortion in your training. So this can mean not so much that the data itself is already biased, but that your selection of what data to train an algorithm on is unrepresentative and as such biased. So this is what happened with facial recognition software being predominantly trained on light-skinned faces and thus not recognizing dark-skinned faces. For our algorithm, for example, the one I asked you to vote on, I showed you four of us, me, Tisha, and Amanda, and Ethan, who's actually written part of the code that we use in the workshop. It's unrepresentative in a number of metrics, right? Age, we're all sort of in a relatively small age range. Employment, we're also employed, all of us, by the same company, so it's even more narrow. Our location, etc. So it's you can see how there's constraints to the data set. Second, what we have to talk about is the use of proxies. Something like a good hire is not something that is representable in numbers. It cannot be measured. What we try to do is program the improgrammable, right? So what you then have to do is you have to use something, a proxy, a data proxy, as a stand-in for a good hire that can be measured. And that will always be an imperfect model, right? So we're using, in this case, the amount of kids you do or do not have as a stand-in for financial responsibility. The same goes for creditworthiness, right? Which is where a lot of algorithms are being used to determine creditworthiness. You may think that that's more straightforward, but if you think about it, the way they're measuring creditworthiness is by looking at how you paid back your credit in the past, when they're actually trying to predict how you'll do so in the future. So that's a data stand-in, a proxy that we say, well, I feel maybe more comfortable using that as a stand-in for creditworthiness than I do the number of kids for, financial responsibility. But consider that even in credit scoring, stuff like postal code and zip code has also been used with all the detrimental effects to that. So what we have to think about when we're deploying these algorithms is really, what am I using as a proxy, as a stand-in for the thing that I'm actually seeking to measure, which is by definition something in the future that you don't know yet. The second thing is we have to think about how we actually frame what the solution is. Something called redundant coding is when one variable that you're measuring is actually already present in another variable in the data set. So for example, one of the most known proxies for gender is a lower average job tenure for women. Some women, right, will leave their job for a while to have kids. So that affects their overall job tenure. What happens then is that in a data set, even if you take gender out of the equation, you can still find the women in the data set because on average, they have a lower job tenure. This again is what happened with the Amazon hiring algorithm. It found data stand-ins, proxies for particularly gender when it was deployed. So if you, for example, had that you were president of the all women's tennis club, it would already kick your resume out, even if you never mentioned your gender. Similarly, language use that is more associated with women was coded against in this algorithm, right? So there's these data stand-ins that occur in how you frame your problem as well as in your solution. So, for example, if I take our algorithm, right, we say I don't want my hiring algorithm to be ageist, right? So I take out the question about age, but then amount of children, if I'm asking about how many children you have, that may actually be a proxy variable that allows me to sort for age. Finally, the notion of scale, right? When you're designing an algorithm, ultimately what you want to do is you want to automate decision making, and you want to be able to do that more than once, because otherwise you've done all that work for once. So what you want to do is have an algorithm that is, as they call it, portable, right? So that you can take it from one place and introduce it into a next. The risk with that is that you're creating, a system in one context and expecting it to seamlessly translate into another context. So this is called emergent bias because it only comes out as the algorithm is sort of like in use, right? So it emerges in that case. Think about the places in which an algorithm having something like early rising is an indicator of a good hire. Remember the question that I want to say Roberto asked about what kind of job, right? Because if I say, okay, I've actually, I've gone to Silicon Valley events and I've designed an algorithm that finds good hires for people, it means they have to get up between 4 and 7 in the morning. And I go to a bar or a restaurant that's open till 11, 12, 2 in the morning. And I tell them, here's a great hiring algorithm. And it will filter people for you that will be perfect for this job, except that it won't be, because if you have people that need to get up between 4 and 7 in the morning, they're not the ones that are going to want to work in a bar till 2 in the morning. So you have to think about the scalability or the applicability or the limits of thereof of your algorithm. And similarly, if you build an algorithm today, it may not hold true for the standards of tomorrow. It's important to think of these limitations while we construct, while you're constructing the work that you do. What if I had a characteristic that asked, like, how many days a week do you work? Today, if that algorithm found people that work 5 days a week, that's considered normal. Back when we had a 6-day work week, that would have been kind of not the people I wanted to attract. And in the future, if we're working towards a 4-day work week, I don't want those overachievers that work 5 days a week, right? So it's really, you have to think about the limits of scaling. So what all of this is really to say is that it's very easy for us to point fingers to say, hey, you know what? Amazon has a super sexist algorithm. Boo-hoo, bad on them. But the only thing we should actually be doing is to self-reflect, to understand what kind of values we're programming into our algorithms and to diagnose and address those in our own work, right? So going through understanding this and recognizing bias doesn't make you unbiased. You just have to think about what the kind of biases are in your algorithms that you are okay with, and being aware of those, because you're not going to get rid of them, but you have to counteract them by introducing fair and equitable and just countermeasures. And yes, that is exactly, so I see in the question, like, what about two opposing algorithms that question each other like the devil and angel on the shoulder of people in vintage cartoons? Exactly those kinds of countermeasures. Is that what I mean? I think I would say maybe go against automating those equally, right? Because you don't know how much you're coding into those as well. But auditing algorithms in that case is a very important step, right? Understanding where actually the things in your algorithm are being weighed. And in the design of that, I'll show you this. We use this in the workshop. We have people go through questions as they're designing these algorithms of like, how does my background, how do the proxies I'm using, how does the scale I'm looking to use, how does it influence the outcome of what will inevitably come out of my algorithm? This is before you audit, right? This is in the design. But you have to remember that things like integrity and financial responsibility are completely cultural concepts, right? What may mean financial responsibility to me does not mean that for another person. And when we mash those together and we come up with some like generalization, we don't know what kind of blind spots we're programming into that. And of course, we also have to take into consideration that in doing so, we may be actually placing weights on proxy variables for protected classes. So that's really what I wanted to talk about today, because we've talked a lot about how we at SU think about the implications of our technologies. And this is really a deep dive into one of them, right? So just some takeaways, because I like those. One is that decision-making algorithms really represent a lot of human decisions, and they have a lot of human decisions in the design process. And all of that human messiness becomes automated and augmented. Two, there is no such thing as a bias-free algorithm. Algorithms operate on biases, they need them, but not all of them are intended, desired, ethical, or legal. And to effectively use decision-making algorithms, you need to be aware of what biases are reflected in your algorithms and your decision-making systems, and correct those that are problematic, unfair, unjust. Awareness about your blind spots and about what your goals are is crucial in this. So that's really all I wanted to talk about. I have some time for questions, I think. So let me stop with obviously this. And the other thing I wanted to end on is that we've talked a lot about this today. Again, this is the QR code if you want to have the preview for the paper we wrote at SU about sort of like how this will affect your business a couple of months ago. And I'll highlight again that, you know, we talked about some of the regulations that are coming, following exactly the patterns that we're seeing, right? People will have to backtrack sort of where they've deployed them before and now doing so justly. So you can download that there if you want. And with that, I will take some questions, but I think Fabrizio may have to jump to support another session. So I don't know how we're going to do that. But if you have a question, just ask me and I'll try and see if I can get them up. Oh, here's Fabrizio, I think. No. There he gone. He's gone. Let's see if I've missed anything in the chat. I also just want to highlight, I love Roberto speaking up all the way at the beginning. That's exactly the kind of behavior that I'm hoping to train, right? That's exactly what we need to do. When someone says, hey, I have a hiring algorithm, it works great, that you then ask a question, okay, but what kind of job does it look for? What kind of, you know, what is it actually looking for? Those are the questions that we need to ask ourselves. So I'm always very pleased to see someone do that. Let me see. Okay, see if Fabrizio is here.
Yes, I'm here.
Ah, perfect. Do we have any Q&A?
There's a question in the Q&A. You can click on Q&A, you can read it, or I can read it for you if you wish.
Do I know where this is?
In the right bar, there's chat, pool,
Okay,
Q&A.
I think a good amount of mindset diversity is winning point. Imagine a perfect algorithm. Will it select similar people even with similar mindsets? I'm not sure I understand the question. Roberto, would you mind telling us your question? If you can raise your hand, you can. I can talk to you directly, which I always prefer. Hi, Roberto.
Hi.
Hi. Could you explain your question, please? Or
Okay, possibly I understood why Amazon didn't select me.
yeah.
Okay.
Yep. Sorry.
The question is, I know that probably I was selected by those algorithms.
Mm-hmm.
So I'm very interested to understand what are the minus and plus of this system. Obviously, companies have thousands of CV, receives a lot of CVs, so there is the need to have something automatic to do a first selection of the CVs. But imagine the perfect algorithm in a company. Will it select equal people with the same characteristics, with the same mindset? I think in a company, a diversity, a variation in the mindsets of the of all the people is a precious thing.
Yes, exactly. So that you're highlighting two things that I really love. One is that, I don't even know where to start. Two things that I really like. One is it will continue to hire more of the same, right?
Yeah.
This is one of the things I think that are sort of central paradox of our time, if you will. All of us, singularity mindset, it's like we're going through the time of the greatest change. Like our generation will see the greatest change, and like, okay, we can have some caveats with that as well, which I'll save for here. But the way we're approaching that is by a technology that replicates more of the same.
Yeah. Because
that's what an AI does. Right? It learns from what was already there and it applies it to the future. However innovative your machine learning is, however, it will not come up with something truly new. It will come up with something that may have been there in the original data set that we didn't see, but it can't create something new. So we're approaching this and this is what I think when it comes to hiring and it comes to any way in which we would apply a decision-making algorithm is sometimes the answer to the question we're looking for is something we don't know yet, right? Sometimes we need to be presented with something we hadn't thought about maybe actually being very useful. And if we have, and this sort of leads to the second point that I hear you make, if we have, and I'm seeing a lot of these technologies being used in exactly this way for AIs to do what maybe can best be described as sort of like triaging, right? Where we see a first selection being made by an algorithm, and only then do you get to the humans, right? It's like a human chatbot saying like, okay, you can go to the chatbot, you can ask your questions, and only if it really doesn't work do you get to speak to a human. For me, the problem with that is even if it's the perfect algorithm, is you need a human in the loop, right? That's the term. The human needs to be in the loop, and that human needs to be able to check or gut check or counteract every decision made, not after the fact, right? And so there needs to be some way in which that algorithm doesn't make the first decision, but even that first decision is in some ways, and you can do this in different ways, right? You can do this by auditing, you can do this by having sort of like standardized, randomized tests of the results of those first decisions. It just means more work. And that's where we see a lot of companies unwilling to put in that extra work, because it looks like, okay, well, we can't deal with all of these requests, so we're just going to put an algorithm here that makes a filter, and then that's where the humans come in because those are more expensive, and etc. And so we need actually humans in this part as well, because we need them to check the decisions that are being made here, either in real time or after the fact, and to strengthen the actual feedback of that mechanism. So I love that you've highlighted those two things. To me, a perfect algorithm is an algorithm with a human in the loop.
Yeah, okay, good.
Thank you so much for your question. Fabrizio, is there another? No, that's it.
Yes.
Okay.
And also to reply to Roberto, here in Europe we have these ESCO database that is trying to track not only skills, but track skills based on projection into different categories and different professionals. There's a company that I'm helping on the AI side that also put in, let's say, in the same database passions to try to track motivation of people and try to create a perfect matching as you defined before. I think it's a very long path, as Alex says, and also today the machine learning algorithm is based on reverse engineering of success stories, but probably is not the best way, but it's a starting point. So the idea for them is to create a perfect team where you take in consideration not only the skills, but also your passion and the way you're learning and the way you interact with other people. And so I think good simulation could also, if you're talking about different reality, VR, for example, having simulation of different things could happen. And when you can create some kind of teammates or team working or team relationship to evaluate how people will react could help to populate and feed this algorithm.
Yeah, and it's funny, right? Because in a lot of cases, actually, around VR as well, we saw sort of like the nefarious effects of some of the biases. I remember the first Oculus, there was massive, I think it was Oculus, I forget. Don't want to blast Oculus if it's not them, but there was massive problems with women becoming incredibly more like motion sick in VR than men, because they tested it only on men, and it turns out that the curvature of your eyeball will actually be affected by the way in which you engage with a VR headset. And because they hadn't tested VR headsets on enough women who have a differently curved eyeball, they became much more motion sick, right? It's those kinds of things that really highlight us to the fact, and that's sort of an example of one of those like a biased data set or an unrepresentative data set, because how would you know that these are things you need to take into consideration if your training data doesn't reflect them? So it's a fascinating sort of thing that really affects all of the ways in which all of us think about how we design and deploy our technologies, not just in AI, right? It's just that in AI, because you're automating something, what happens in an example like a VR example like that is women start complaining. They're like, why do I get motion sick all the time when I'm in VR, right? Because they're allowed to speak up. If you're going through a hiring process and you're just never called back for anything, where are you going to complain? What are you going to do? They're just going to say, yeah, you didn't meet our criteria. Right, so that's a difference in motivation in if it turns out like swaths of women are saying like, hey, you know what, I get motion sick in VR. That's in the interest of those people developing it to actually make it better. But from the point of view of someone creating a hiring algorithm that way, they're like, yeah, it works fine. We got great resumes, but you don't know what you've missed.
Also, there is, I think there is a certain level of risk that an HR typically doesn't take and avoid. And probably also programming or using algorithms, it will take the same approach. Sometimes there is a need to, okay, I bet on this person because I feel that there is something good, and probably it is the one that could change something in my company. And algorithms HR typically doesn't take those kind of risks.
Yeah.
So
yeah, that's exactly sort of like going for that unknown that you can't put into words, but it's there, right? It's that's exactly it. Yeah, that is exactly it. And oh shoot, what was I just thinking about as you were? Well, it's to do with, well, yeah, I think it's to do with what we think we can capture in data, which is often just actually, I just read a book, I forget the author, Christian Mudgebjerg, who differentiates thin data from thick data, whereas like all of our algorithms are basically trained on just like quantity, right? Just having 100 examples is better than 2. And thick data is more where it's sort of like it's actually quantitative data. And he does a really good job of explaining some of the, you know, some of the differences in how we approach qualitative and quantitative data, whereas really so most of our technologies can actually only deal with just a ton of the same kind of data, right? Like 100,000 pictures of a cat, but not understanding anything about that cat, but just about the pixels that are represented in there. So it's an interesting thing that I think we should be careful about, trying to capture all of that in data-driven systems, when in reality it may not always be possible to capture just that, because of the way of these how these technologies work. What I will say is that, as I mentioned as well, is, you know, this notion of being able to make explicit what was implicit before, that can be very powerful, right? And there I do see, I think there is a huge opportunity for us to actually think about what has been implicit in the past, and if we were to train an algorithm, that it does become explicit. So let's say I don't know, hiring person, an HR person, right? And they keep hiring people, but you feel like something's a bit off, and you're like, seems like you're really only giving people a chance that are kind of exactly like you, right? And then if you were to say, well, let's look at the data, let's train an algorithm on exactly the data, then you could make explicit what is otherwise implicit. And the other thing, well, there's one more thing that I find a lot in when we run this workshop. We run the full workshop, right? The 4-hour one. We do that either with managers, so people who have to sort of tell people to build algorithms, or we do it with engineers, right? Which is really fun because they're the ones that are usually told, go build me an algorithm that filters people. And, you know, the questions we use are purposefully silly, right? What Hogwarts house are you in? How much water do you drink a day? Whatever. But the engineers tell me that's exactly the kind of data they have, right? That is exactly the data that they're told to go build something with. And then, you know, there's managers say, yeah, we have plenty of data on these people. Just go build me an algorithm that finds these people, right? So it's a responsibility we all have to carry in terms of being responsible with our data, with how we deploy it, how we apply it. And often we can say things like, you know, our intuition, our gut feeling can be, oh, it has to be that way. And we can actually use these technologies to figure out what is hidden in the implicitness of that technology. Oh, we have another question. Sorry. Okay. Trevor. Hi, Alex. Do you think it's best to have individual organizations to monitor their own biases, or rather some external entity that will specialize AI law? That's an easy answer. External. I think when we've seen, this is something that, of course, within Silicon Valley, everyone's like, no, regulation stifles innovation. We need regulation. We need regulation fast, and we need external regulation, because we've seen what companies will, and most importantly, won't do when it comes to holding themselves accountable. I think I'm a firm believer. This is obviously question up for debate. From a personal point of view, I believe regulation, external regulation, is the way to go. I have read some of the regulation proposed by the EU 2 weeks ago. I think there is a lot to be, you know, improved upon there. One of the things that's in there is sort of like, we need a single universal definition for
Alex, may I ask you to, because I have to close your session, sorry, I have to jump in another one, but I don't want to interrupt the conversation. So what I suggest is that you, Roberto, and anyone interested to go deeper, move to your table
Okay, yes,
at
yes. We have a
the
table
Singularity booth. So I will stop the session. You
Yes.
will go to the lounge, click booth, go to Singularity. You will see a lot of table. You can have this fantastic conversation move forward. Sorry to
Sounds good.
for that.
No, you're absolutely right. I completely lost track of time. Thank
No,
you
but
so
it's
much
good.
for
It's
having
good,
me.
Miss. The conversation was great. Really appreciate it. Sorry, guys.
Yes, I will go to the Singularity booth.
Fantastic. See you there.
Bye.
Bye-bye.
Bye-bye.